All right, class, so today we covered chapter 4-7 in the red book, slope-intercept form. Slope-intercept is y equals mx plus b, where m is our slope and b is our y-intercept. Spent a lot of time identifying slope and y-intercept and why we call it that. And it's called that because you can easily, so right here, why is it called slope-intercept form? Because you can easily identify the slope and the y-intercept when it's in that form. Then we went through and we did a couple examples. So in your notes, what is your m here? Well, what's corresponding with the m here is what's corresponding with the m here would be, so that would be -2. And our b would be +4 because that's in the spot of the b. All right, over here we would have 1/3 as our m. Then we would have -6 as our b. So we have to incorporate the value, so the negative and the positive, within the problem. Don't worry too much about this problem. We're going to cover that tomorrow in class, but we did cover it in class today in your notes, but we're not going to go over that in this video. So the next part, after we've learned how to identify the slope and the y-intercept when it's already in slope-intercept form, we talked about how to graph a line on a coordinate plane. So the examples they gave us in the book, we're going to go over those, and then I'm going to go over two additional examples of things you're going to run into in your homework assignments or any other type of problems you may see. So y equals -2x plus 3 was our first example in the book, and we're going to graph that on this graph. All right, so going over kind of our rules. We always plot the y-intercept, or the b, and that's going to be our starting point. So if we look at this problem, we identify our b, which is +3. We go up to 3 on the y-axis, and we put a dot there. So that's where we're going to start our counting from. Next, we count our rise over run. Now, in the previous chapters, we've talked about what our rise over run means. Our numerator is either going up or down, and our denominator is either going left or right based on values. So positive is up, negative is down, positive is to the right, negative is to the left. It's on the numerator. So I'm going to take this -2 and I'm going to turn it into a fraction. That's what step 2 is talking about. We identify the slope as a fraction. My slope is -2. So to make any whole number a fraction, we just put a 1 as the denominator. So we have -2 over 1. So now when we look at this fraction, -2 over 1, we do what it says. Remember, the numerator is going to tell us whether to go up or down. So since it's a -2, we're going down 2. So from this point, we go down 2 spaces, and then the denominator is a +1, which means we go to the right one. So we go down 2 to the right 1, we put another dot there. Then we can draw our line through that. That is our graph. Example 2 from the book was y equals 4x minus 5. Actually, I'm going to do number 3, which is y equals -2/3 x plus 2. So y equals -2/3 x plus 2. All right, so the order doesn't change. We start by plotting our y-intercept, which is a +2. So we start at the origin and we count up 2, and we put a dot there. The other day we talked about equivalent fractions with negatives and positives. So if the negative's out front, we either have to think of this as a -2 over +3 or a 2 over -3. And I'll graph both of these. You can see how they're going to fall on the same line. So if I have -2 over +3, from this starting point I go down 2, because that negative indicates down. So down 2, and then to the right 3, because this positive indicates to the right. So that's that one. Now in green, I'm going to plot this point. So if I go from my starting point, I have a +2, that means up 2, and then -3 means to the left 3. I can put a dot there. You can see how they line up. So they all fall within the same line. Those ordered pairs all line up to form a nice line. And we talked about yesterday positive and negative lines and which direction they go, and you can see that these are both negatives. And I'm going to do two other examples just for you, just so you have it for reference. The first example is if we have y equals, let's just say 2x, and there is no y-intercept. You don't see a plus b in this problem. Well, if there is no y-intercept, your b is 0. So you just put it right at the origin. All right, and then here we have a 2. We can make that a fraction by putting 2 over 1. So from this point, I do what it says. I go 2 to up and to the right 1. All right, the equivalent fraction of 2 over 1 using negatives would be negative 2 over negative 1. So you can also do down 2 and to the left 1, and they'll still be lined up. All right, so when it's a good point to understand this concept is this: let's say we have a graph y equals 5x plus 10. All right, so if we graph this line, I'm going to draw my coordinate plane. I'm going to do this. My starting point is a positive 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a dot there. All right, so from there, I need to do my slope. In this case, my slope is 5, and to make that a fraction, I would do 5 over 1. So if you notice from here, if I go up 5 to the right 1, I'm starting to run out of paper. I'm going to run into that, so it's going to be messy. So we can also think of this as negative 5 over negative 1, because a negative divided by a negative is a positive. So if we do this on our graph, then I can actually get back onto the graph so I'm not using up more paper when you're doing your homework. So I can go down 5, 1, 2, 3, 4, 5, to the left 1. So 1, 2, 3, 4, 5 to the left 1, and I can just indicate my line there. All right, so hopefully this helps. On today's assignment, it was all of the problems were in slope-intercept form already. When I say slope-intercept form, that means y equals mx plus b. And we call it that because you can easily identify the m and the y-intercept. Tomorrow we're going to talk about when we don't have it in that form, how we can get it there so we can easily graph it.